attending my talk. So my talk is on load testing against Azure Kubernetes, and also looking at some of the monitoring tools. So just a little bit about myself. I've been working, I think, 14 plus, maybe 15 years now, 16, on Microsoft technologies. I've, worked with a range of technologies: Azure, SharePoint, Microsoft 365, and more recently on Kubernetes, and I'm really enjoying it. So I'm a 5-year Microsoft Azure MVP. I'm an independent consultant. You can check out my website, my blog, and graduate from U of T. So to get right into it, the agenda would be just a quick overview of what AKS is, the concept of auto-scaling in AKS, load testing tools, and monitoring, and some of my best practices kind of in the real world, and from in some my projects, and then we'll end off in Q&A. So let's see here. So so what is Azure Kubernetes Service? For those that are kind of new to it, haven't really dug into it that much, it's a managed container orchestration service. It provides, kind of load balancing, auto scale, pod container deployment, health monitoring. It's basically it's a kind of a managed service to host a Kubernetes cluster, okay, and host many applications within it, okay, or a few or many, like huge, large applications, especially around a microservices architecture. So I like to describe as Kubernetes in Azure is kind of like a micro data center, because it's jam-packed densely with kind of compute and storage, and you can networking, different OSs, that meaning Linux or Windows, and because of container technology, you can have many frameworks, operating, frameworks and different programming languages running on it, etc. So, so that's what basically AKS is in a nutshell. AKS is also divided into kind of two areas in its architecture. So one is kind of customer managed, right? So that's like basically a cluster of nodes, okay? And it has deployed like Kubernetes bits, like kubelets and its container runtime, in order to host a bunch of containerized applications. Okay, so these are really Azure VMs behind the scenes. But then things that's, and the left side is Azure Managed, which is kind of like your controller, right? What's an API server to do administration, schedulers, kind of for more operational management of your cluster. In your etcd, which is kind of your database of kind of your holding state with your cluster, not database of your application. So this is pretty much a black box on the left, okay? And so what you can get out of AKS, so here I have my own little architecture diagram where I have many applications. So I have a kind of a voting application. I have, so we call book info app, guest book, simple hello world. And so all these applications are organized into their namespaces. And then on the left side here, the ingress is how to expose these applications external to your AKS cluster, okay, your Kubernetes cluster. And in a cloud world, that's driven by your cloud load balancer, right? So the Azure load balancer, and then out to your client, which is your browser, right? So, in comparison, like, Amazon, Google has their own AKS equivalents, like GCP for Google. And so, for the ingress, you know, it would provision their own load balancer that they have, right? So to have traffic into your cluster, okay? And then we have operational applications such as Prometheus, Grafana, which I'll show as part of this talk, and Kiali, which is kind of showing kind of your visualization of your service mesh, because I have Istio service mesh installed and used, and then your Cube system, which is your kind of your out-of-the-box kind of Kubernetes, your guts, you know, so system stuff, okay? And so I'll kind of show how to do kind of a load test against all these apps at the same time and kind of see kind of what that load would look like. So let me revert to, let's see here. So let's go into this, kind of this test VM here, so that you kind of see what's happening in this environment. So, you know, there's this guest book app, you know, I'm hosting, and you can, you know, sign into it, you know, John, Bill. That's a very simple app, okay? Another one, this is a very extremely simple Hello World app in there. This is a bit more sophisticated. It's called the Book Info app. It's part of the Istio demos, right? And let's see here. So you click refresh. So it's just basically getting book reviews and their book reviews for various books. And let's see here. What's another one? Whoops. So I think I have another one where it's guest book. Oh yeah, voting app. So you can vote on cats and dogs and reset. So the whole point is I got a bunch of apps that I've deployed and, you know, set up networking and, you know, internet facing and all that stuff, right? So the thing is now is, okay, how do we do load testing and how do we monitor these things, right? Because, you know, going back to my, let's see here, this application and this architecture, well, the whole key value proposition that Kubernetes provides is stability and resiliency. Okay, so let's say that you have a lot of load that's onto all these apps. You know, can it scale properly? You know, how do we? You know, they're all competing with resources behind the scenes, like compute, memory, you know, network bandwidth, etc. Right? So first thing is, how do we do load test? What are the different options? And secondly is, how do we monitor, see the performance metrics? Okay, so I'll pause right here. If anybody wants to, in the chat window, have any questions, or they want to come off mute, you know, I encourage you guys, let's make this a very interactive and collaborative session so that, you know, you guys can, you know, take away the most you can with this kind of your valuable time. So any questions?
Is the what you're talking about, is it only applicable to Azure Kubernetes, or is it applicable to Google or Amazon services?
Oh, you mean the load testing, or
the load testing part? Yeah.
yeah. Oh yeah, it's applicable to any application, like any hosting cloud, you know, even Azure App Service, or in, you know, in anywhere. So yeah. So the tool itself is not specific or anything special to AKS, but, you know, I want to demonstrate that scenario of kind of load testing and performance. But yeah, that's a good clarification question before I jump into that. Anybody else? No? Okay. Okay, I'll move on. So yeah, I just talked about the different applications that I'm hosting in here. And so so what are some load testing tools? Okay, so there's many out there. Okay, but these are the ones that I've worked with. So so JMeter is the one that I've got some experience with, and it is pretty powerful. It's free. The UI is not intuitive. Okay, I'll show you that in a moment. But once you kind of get the hang of it, then you know what, it's not too bad. But man, it was very counterintuitive how the UI works. There's many powerful features and plugins and things like that, right? So you know, check out JMeter. Okay, and then we also have Seige, which is more of a command line tool. Okay, we've got some time, we'll kind of look into that. So it's simple and easy. It's not as powerful as JMeter, but it's free as well. And you can, you know, the whole thing is you can build automation scripts using that tool as command line. Actually, is JMeter, is there command line equivalent? Probably there is. I haven't really delved into it. Siege is kind of like Linux based, right? So JMeter, you can do it, it's Java based, but yeah, you can load up in Windows, Linux, you know. My longtime favorite is the Visual Studio Web Test because, you know, I use Visual Studio. That one is very easy and very intuitive, but the bad thing is it's now deprecated. There's just the last many years, it's just no longer supported. Like if you load up Visual Studio, especially the latest versions, I think even from version 2017, maybe, I'm not sure. It just, you won't find it. You know, they're just not there. You can't load it up anymore, right? But you know what? I think UI testing has become more sophisticated, especially with single page apps, and you know, so Visual Studio, I don't think they really kept up anymore. And even if you go to the documentation in Microsoft Docs and you search for like load testing tools or performance testing, and you search under the Visual Studio Web Test, it will actually recommend you to use JMeter, right? But Microsoft has no like association or partnership that I'm aware of with JMeter. They just kind of punch you to JMeter. So I just, you know, for those that are, .NET people, this no longer applies. But I just had a pretty good experience with that on just very quick and easy load testing. Okay, so let me see.
I can totally agree with that.
Oh yeah, totally. Yeah.
I used it lots, but they just coded UI. They said use Selenium, and web tests they said use JMeter, and we're not supporting it anymore. Unfortunate.
Yep. Yeah, it's very unfortunate. All right. So actually, when I tried the Visual Studio Web Test, the latest that I could use, yeah, it didn't work. Actually, just I pointed to it. I would like just hit run and load test against it, and I don't know, because I don't know. I think just HTTP protocols, it's just not keeping up to date with what's happening in the latest web world, right? With protocols or JSON or I don't know, like, you know, just Ajax or whatever. So it just doesn't work anymore. So okay, I think I see a chat question. I can't. Okay, so from Jimmy, are those 3 tools for application level load testing? Can any of them do network level latency load testing? They're generally for application load testing in terms of network level. So what do you mean by network level? Like TCP, like kind of like a layer 3, layer 4 kind of packets, like that kind of level? Like if you can clarify. Yeah, not that I'm aware of, but that's interesting. I never thought of that testing on that level. But I'm not sure if they have such functionality in those cases. But that's an interesting point. Not that I'm aware of, right? But you can do, I guess, network level in terms of packets, like from an application perspective, and you can see some network level. I'll show you that with the monitoring tools. We can like dive into that. Okay, yeah, awesome. Okay, so that's just, I'll get into this. I just want to go through some slides. So really, the way that I see load testing work are like 3 dimensions, okay? So one is in a load test, you want to set up your users and threads. Okay, so these are your virtual users, right? And really, load testing tool can be multi-threaded, right? So each thread is kind of simulating a user, and they're like click, 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 you know, and then as they're clicking away or putting load on your application, each like you can say that, okay, transaction 1 is a click, transaction 2 is another click, up to transaction, and you can kind of loop through, like, you know, like for example, log in, you know, click on a search for products, click on a product details, put in the shopping cart. And so that can be a sequence of transactions, right? And then multiply that by various like APIs, so yeah, APIs. So you know, a lot of applications are API based, right? So you know, API 1 can have transaction 1 to n, and then have API 2 transaction 1 to n from that same one virtual user. And you kind of put them in a sequence or kind of loop through them, and so that will demonstrate kind of this line, this, you know, this 2-dimension. And then at the 3rd dimension is you have requests per second, right? And so like how often or how quickly like these virtual users, either one or combined of all these virtual users, have how many requests per second, you know. So that is the load part, okay, that you're putting on, right? So that's how I see it, and that's kind of how I model kind of my load testing, right? Is number 1, you want to kind of make a script or kind of how your users are interacting, like I just mentioned, log on, search, click, shopping cart, buy, right? And then maybe another scenario, which is, you know, they may just kind of browse through applications, or they may add like product reviews, you know, those things. That's another kind of series, and then put them all together, and then you have multiply that with many users, and then you can simulate how aggressive or how heavy they're all doing those things. You know what I mean? So you can do it by having each user like a quote unquote like really quickly, right? Or have many users and threads, okay? So that comes to like preparing your test rig, right? Your virtual machine. So in this case, in this one, I have like to do the type of testing that I want to do as like 16 gigs of RAM. It's just an Azure virtual machine, right? So let me walk you through how this tool works. So, you know, anyone work with JMeter? You can just say in the chat window if you have or haven't, so I can kind of gauge the audience, any JMeter use. Okay, so, all right. I'm gonna stop here. Gavin says no. Lloyd says, oh, Yusuf, yeah, you've used it. Okay, awesome. Okay, so, okay, the way that this is structured, okay. So I have here, okay, right at the top is just like a logical kind of headers, like my ROIKIM AKS solution, right? And then so I have one here, one app, .NET Core, SQL, DB, RKIM.ca, which is, I don't think I showed it right here. So let that load. So it's kind of that. So my test is very simple. It's just doing a read. It's not really doing the updating of data. No, it's just read. So it's just keeping it simple. So I have this app, guestbook app, a WordPress app. You know, let's see. I think this may not be working, but I just want to see if it loads up at all. So, oh, it does. Okay, cool. It works. Okay. Now we have that app. We have the AKS Hello World app, book info, voting, etc. Right? So these are grayed out. Okay. Hopefully you guys can see my screen. I can't really make this bigger. There's no option. It's just it's, you know, It's not web-based or anything, so it can't make it bigger. and then so what you do is, okay, we'll run through this. You add like a name to it. I just put the URL as a name, and then down here, you put like HTTPS. You put the server name, like the URL, that you want, right, or the host name, and then you can put like the path, right, URL path. In this case, here, this is a good example where I actually use the URL path, and you can get more sophisticated by, adding some parameters like HTTP parameters, HTTP headers, query strings, even body of the file, things like that, right? So there's some neat capabilities, some things that are more advanced here, which I won't go through, but it's got a lot of capabilities here. Okay, and then so really what I did here is I just lined up all these, okay? And in terms of, if we get back to here, the thread group, okay, how do we configure for number of users, okay? So what I have here is 500, which is pretty aggressive, I have to say, for one virtual machine here. And let's see here, task group. Let me see here. So I have about like 16 gigs of RAM. And so it's pretty compute heavy, the way that I have set things up here. Okay, ramp up period. So usually when you start up a load test, you don't wanna, you wanna let it slowly ramp up, not like 500 users or 500 threads going all at once. Because you know what, it's not realistic, and also it may kind of really bog down your application. I mean your hosting rig, your testing rig, and also you want to see the progression when you're monitoring. You want to see the progression of load acting on it, right? If you're too forceful, it may not be realistic, and then it just kind of bring things down unnecessarily. But it's still a good test case to do like a very aggressive right up front. So here, the loop count, right? So each virtual user, they'll kind of loop through their activities. Okay, so really what's happening is this is like a user will click on this, will then click on this, and then this will loop through like a virtual user. Okay, and then we're doing it loop count infinity. Okay, or you can put in a set number. Same user on each iteration. You can say delay the thread creation, etc. Right? So the duration of each thread or each virtual user is 2,000 seconds, however long that, which is 50 minutes. Okay, and so really this is happening 500 times. Okay, 500 virtual users, they're all clicking away, and then in this cycle. Okay, so the way it works is that you kind of add samplers. So the one that I did here was a HTTP request, okay? And you can do other samplers, or such as, even FTP, JDBC request. Oh, actually right here, TCP sampler. So the question before, can it do network testing? So yeah, I think that's what this is about, right? A TCP sampler. And then you give it necessary, configuration, and maybe that's kind of what it'll act on, So there we go. So I'm just gonna remove that. Remove. So we have here add samplers, and then you can have logic flow like if statements and all that stuff. Assertions. Okay, so whoops here, assertions. So does it meet certain conditions such that it's conditions are true? Pre-processor and post-processor, how you want to like massage the data that comes out of it. Timers. Uniform. on a certain, like intervals, that you want to program. So really, all this stuff right here is that you can basically program how things are executed. Okay. Now, the way it's structured is hierarchical, right? So, and that's the part that will, at least to me, was counterintuitive, right? Is that if you want to have if logic, you would place your, let's say, logic controller if controller, you got to move it up here, I think, and then it would and place it underneath, right? Things like that. So anyways, I won't go deeply into that, but the point is that it's hierarchical in nature, and so you have to have that kind of mindset into it. And then at the bottom here are your set of reports, like how you want to monitor the execution. So a summary report, your label. So these are your transactions. Response times, your average, min, max, error rate, your throughput, and all that stuff, right? So this is pretty helpful. View results. So let's do this. Let's run it, right? So I'm gonna broom, like clean up the data here. So I have a response time graph, view results, graph results. So I'm gonna kick it off, hit play. Okay, and then give it some time. So so how I add these pink ones are listeners, okay? And really it's, think of it as, outputs, of your test. Okay, so these are the ones I added. So view results is just as you see it as they come through. Okay, and it's all green. That's pretty good. Scroll automatically. So that's working well. And then we can see kind of in real time, kind of the stats, the metrics here, how often. And then we have response time graph. Okay, so this builds up as your test executes. View, another form of view results, like tables. Okay, this is similar to summary. Backend listener, I don't really use this that much. Aggregate report, graph results. So this is pretty cool. Okay, any questions so far of JMeter? Okay, cool. Another tool I'll just talk about very quickly. It's free. Is the Seige.
I'm
So
sorry,
right
Mike,
now,
I have a quick question.
yeah. Okay, yeah, go ahead.
So how's this? So you're testing the web end, right?
Yeah.
The web endpoint.
Yes,
HTTPS endpoint. How's this
correct.
Kubernetes related?
Oh,
What's special about this for like Kubernetes wise, right? What extra consideration you have to take into account? What extra information should be collecting, should be getting, that kind of thing.
mhm. Yeah, okay. The tool itself has any special relationship with Kubernetes, right? I guess what I'm trying to demonstrate is Kubernetes that can host many applications kind of under one roof, and kind of see in real time or kind of demonstrate how all these apps are taking on load at the same time under one Kubernetes cluster environment. So
Okay, thank
there's
you.
nothing special. Like this is agnostic to your hosting platform, right? You point to anything like IIS, Node.js, like on your laptop. There's nothing special whatsoever, and there's no plugins specific to Kubernetes. So yeah, nothing in that regard. So, but yeah, good question. And then, okay, so we have that going. A little quick peek into that. So with Seige being command line tool. Again, I'm just showing very simple, like, sudo apt-get, just install it, okay? And let's say, for example, this one. So command line is Seige. -C is kind of how many concurrent requests or like virtual users. How long I want to do for 900 seconds, and also right. So it's just a very simple like tool for that. Like run. Let's see here. Go. Sorry, run. Start debugging. Oh, whoops. Sorry. Okay, selection. Okay, you know what? Let's do this. Let's put it here. Paste it. Oh. Oh, you know what? I did not. Let's see here. Okay, I think I had to install it. Oh. So. Okay, you know what? We'll just skip this demo. Okay, or maybe we'll come back to it. But anyways, the point is, I like to use this tool because it's like very light and it's very light and simple. So if I'm just doing very quick tests and I kind of want to test the endpoint and then look at the performance of the app and see how it behaves and kind of go back and forth, right? And I don't need to do any quick heavy setup and install this. And so I like to use this. It's kind of your like a screwdriver, light screwdriver, and this is your jackhammer type of thing, right? So that's kind of the difference. So just to give you a variation of what you can do, and of course you can input a input file that has many URLs, right? And then kind of in contrast, just showing what Siege is like. So now let's kind of go to what AKS looks like. So okay, you know that. Why am I getting that kind of login? You know what? This is weird. Okay, I'm gonna go to a different. Sorry. Let me go to from here. So one monitoring tool that you get with Azure. Okay, one option is Azure Monitor for containers. Okay, for Kubernetes basically. So you have so right now I'm in my Kubernetes cluster. Okay, make it bigger. So this is my Kubernetes cluster. Okay, I'll just give you a quick overview. So here's my namespaces. There's the AKS Hello World, book info, all that stuff, right? And then we have your workloads, services, storage, all that stuff. Okay. Let's look at the node pool. So this shows that like, does it show how many, okay, nodes. So I have 1, 2, 3, 4, 5, 6, 7 nodes, okay, in this node pool, and auto clustering is enabled, okay. So that's an idea of how big they are. So they are size, let's see here, let me make this more legible. So the size of these VMs are D2, SV3. So I think that's like 2 virtual CPUs, 8 gigs of memory, I believe. So that's what that looks like. And then, so I see a question here. Let me get to that question. So Anthony, earlier question, why you'd want to load test on Kubernetes when you set up a resource limit request, you'd load test to establish limit, also useful to ensure pod cluster working. Yeah, so yeah, that's a very good point. So yeah, actually that's a very good point. So in Kubernetes, set for each pod, okay, so let me illustrate here, right? For each pod, you set up resource limits, right, or requests. So it's basically that for this like pod, right, or one containerized app, you allocate, let's say, a quarter of a virtual CPU, okay, or a certain amount of memory, okay, and you give it like a soft threshold and a hard threshold, okay, because you don't want to have an application like just taking over or consuming all the other resources, okay. If they do that too much too fast, then you know there could be not enough resource for the other applications, so things get starved. I mean, you know, although there's auto clustering, you know, like you have that, then you know what, all of a sudden like auto scale to like 100 nodes, right? It'll be very costly. Okay, so you know, in those extreme cases where code is built efficiently, very inefficiently, and then it just takes up resources, right? So that's where load testing can test those resource limits, you know, soft and hard limits that you set on each of these pods, and to test the auto clustering. So yeah, thanks Anthony for your point there. It's a good one. So back to okay, back to this part right here. So insights. So insights is a monitoring tool out of the box for Kubernetes. Okay, the data stored in the log analytics workspace. And so I have here, you can set the time range of that, last 24 hours, kind of see some activity. It was kind of like not much activity before during the day, but this is more recent activity, okay? So as you can see here, node CPU utilization, node memory, node count. So if you notice here, the node count has been going up. Shows that auto scaling was happening right here. So this was last night. I did a test. Scaling occurred right here at 5, which I just ran as well. You can see the auto scaling in effect right here. So you have from, let's see here, 7. Yeah, like around, I don't know what it's saying, like 5, 4, 3/4, but it's auto scaled. Okay. Auto scaling the number of pods. So so there's something called horizontal pod auto scaling. You know, I should revert to my slide here. So so I just want to illustrate this point where when you do load testing, you can have in Kubernetes, like for one app to have multiple replicas of each other, okay, as long as it's, you know, pretty stateless, right? So you have like a front end UI, and you can have something called horizontal pod auto scaling, which will make a copy or a replica of each other, right? And internally in Kubernetes, it's like there's like a software-defined load balancer. Right? So you can have like many pods, replicated as it needs, okay, to take on the load. And then what happens is that if a certain node VM doesn't have enough pods to host it, and you have auto scaling enabled, that pod, let's say you have an additional third pod, it doesn't have enough resources left in this first VM, so it created it in the second VM, right? And that's called pod scheduling, okay? And so if another node is needed, what happens is the autoscaler will, kick off another node creation. It's not immediate. It takes some time. It takes like, a few, 5 minutes, let's say, or a few minutes, the quickest, and then it'll eventually generate another pod in there, and then kind of load balance. But in terms of HPA, horizontal pod autoscaling, that autoscaling is pretty fast because loading up a container is literally seconds. Okay, so that's the awesome thing with Kubernetes is that HPA, you get some auto scaling there, but when you're doing cluster wide, that will take some time. So that's the general flow of how that works, right? So if we go back to this auto application, it just shows that the active pod count increases because there was just additional load here, and today there's some more, and then in correlation, like there's more nodes were created in these times. Okay, hopefully that makes sense. Let's see here. The other thing, reports. Reports on there. I don't really find this too insightful. Let's see here. Let's let it. So disk capacity. Sure. Don't find it all that useful in the real world. So here's your nodes. And you can see here kind of 2,000 millicores. So that equates to 2 virtual GPUs. Okay, and you kind of see its usage. Okay, and if you extend this, so and then your other containerized, these are all containerized applications like your pods. So if here unscheduled, this could mean that a node is being provisioned, right, or being deprovisioned. So in auto scaling, you can scale up and then you can scale down. Okay, so that's what I usually see unscheduled apps. And then when you get to controllers, okay, so this looking at the Kubernetes deployment objects, right? And so WordPress has just one pod, but I think let's see here, product page. So product page. Here, so you can see that there's 3 replicas that's been generated. This one would have like a horizontal pod, right? So wait a minute, you know what? Okay, sorry. This one says 80. Yeah. Product page. Yeah, this has been auto skip with review at each container, and see kind of that's not it's just high level. It's hard to look at details, and so this monitoring tool I like to use is Grafana. Okay, so Grafana is tool, and diagram. Okay, it's very clear. So we have here of Grafana he does kind of small data looks into Prometheus. Okay, so here I find much more the Azure Monitor for so here is usage per node, okay, and right down to each here, but each one of these is a pod basically, okay, or a container. As you can see that, well, it's pretty, let me make it without, okay, so this whole first section here was when I launched it before this talk, and then right here, that's the test that's happening right now. So I like how it's being updated kind of in real time. It's easier to see. Memory usage, right? You can see usage. Now, in terms of let's see, Istio. So this is a dashboard by Istio workload dashboard. I like this. This is useful because you can see incoming HTTP requests. Okay, another response code, success rate 5xx, like more like 4. Okay, responses, and it's coming out almost 100% consistently. Response sizes, so you get a lot of more details. Okay, durations, outbound, which is not showing much details, but it's pretty cool. So here you can filter by app. So let's say the voting app. Let's see here. So, and also the various workload. Let's see, let's try to get the right one. Okay, this one has some data that's showing up. So that's kind of how you can toggle between different apps at a very granular level. Let's see here, Redis. So book info, details, product page. So the product page is a lot of load is happening on it. Okay. And inbound workload. Any questions so far? Okay, Jimmy, could you share the example of code and config? Could you share the example code of Prometheus Grafana on a pub repo? Sure, if you email me, I can send that out. Could you, the example code config? Okay, so what I would do, okay, I'll show you right now, all right? So of Istio, okay, you go to Istio and you install the kind of the demo of Istio. And what it is, it has like it's kind of pre-packaged with Prometheus and Grafana, right? Or has instructions to install that. So that's what I use to when I want to get started with Prometheus and Grafana. So Prometheus install, but there's separate applications, right? Here, and you know, you just basically follow this. Sign off forever. Okay, that's a good. Yeah, you just follow these instructions, and there's no code really. The code or the YAML file packages really come from these instructions, and that's kind of how I go about it. So there's many ways of doing it. Hopefully that answers your question. But if you email me, like you know, I can guide you further, kind of depending on your setup, you know, things like that. So hopefully that answers your question. Okay, so so back to this. What's really cool about Grafana is that, see these dashboards, you get them from like a community, like Grafana dashboards. You get them from the Grafana website. So they're community driven. And whoops. Let's see here. What's so for these cluster. So I'll give you an example right here. So so this is a dashboard created by a community member. Copy the ID here. So what I want to do is go, whoops, cancel. Import. I'll have to, and then copy the ID. Select my data source was Prometheus. Okay, and then you hit import. And off you go. Like there you go. Like there I have another dashboard. Okay, showing some metrics here. Okay, let's see here. This one I've never used, but you know, same kind of information between different dashboards being presented in different ways. So that's kind of how I liked. That's how easy it was, as you saw. Okay, got it. Okay, yep. All right. So so those are again in summary, Azure Monitor. Okay, container Azure Monitor Insights, and that has no setup. You just really 2 clicks to enable it. This takes some setup. Okay, it's not very easy, right? But it takes quite some involvement. You load it into your Kubernetes cluster. Okay, and then information. So let's go back to my slides here. So just went through that. Is just another example of response time graphs. Yeah, we talked about scalar, and just so this is the architecture that like the product page, and then some services behind the scenes. Okay, and then ratings, a backend kind of Node.js application. So so finally about horizontal pod auto scaling. Yeah, typically it's kind of based on the metric of resources on a percentage. So, you can set the threshold to be like 50% target. So if it reaches the resources, the CPU is more than 50% that's been allocated to it, then it'll trigger and create another replica. Okay, and it shows down here that events that have happened. So the new size is 1 to begin with, and then new size for resource CPU resource utilization is above the target of 40%, and that's how a new replica is created. Okay, and yeah, just another use of Grafana. So that's pretty much it. And I will go into Q&A, or if you guys want to point something out that I showed in the demos, let me know. But yeah, open up for questions and answers.
I don't have a, you're monitoring the Kubernetes using Grafana that's running on that cluster, right?
Yeah.
I'm assuming it's for the demo purposes, right?
Yes.
Because
Yeah.
otherwise it's
Or
running somewhere else. Like you can't be watching, you can't be monitoring the tool with something that's found in the tool, right?
Yeah. So to be honest, like it's not just demo, like in production, like this is like a viable way as well, right? Like yeah, Prometheus and Grafana do take some resources, okay, but then okay, we can get into the deeper discussion of how resources are allocated, right? So you can kind of box out like Prometheus and Grafana to use only a certain amount of resources, right? Like it's not in my opinion, it's not really going to compete or, slow things down, right? You can even,
No,
if you want to
that wasn't my point.
yeah.
My point was if the cluster is down, your monitoring is down. You don't know that it's down.
Oh, yeah. If the cluster is down, your monitoring is down. Yep. That's a good point. Yeah. So yeah, I believe that it's quite possible to have Prometheus and Grafana on a different cluster, right? Prometheus Grafana is not made for Kubernetes. Like it can be hosted even on a VM as well, right? And so you can have, Prometheus running in this cluster, Grafana in another, or both in a separate hosting platform. So that's a good point. So for in a very, DR or enterprise or very robust architecture, you can do them separately. You know what I mean? But honestly, like from my experiences, like having it in the same cluster, I don't see it as a big deal, especially in production. I've seen it, I've done it. It goes through. There's other monitoring tools that you have to load in that kind of interrogate the list for all the metrics, all the data. So by the way, like you can have like these properties, all everywhere, right? Like for that. Right? So if the cluster goes down, then yeah, you don't, it's you don't, yeah, there's nothing to monitor, right? Once you know that, right? Like you do have, you wouldn't be notified. So, but yeah, that's a legitimate architectural use case. But yeah, you can get around it by separating the two. So, okay, another question. What are Yusuf? What are key things need to be considered when performance for AKS applications? When designing a performance test for AKS applications. So back to other services, etc. Right? Other considerations are when you're designing a performance test. Also, it's also about the Mac. You want to design for what would be the max load. Okay, that's realistic. That's peak times, etc. Let's say for like holiday season, like shopping, just days before Christmas, right? So you have to model for those high load cases, okay? And an expected kind of response time. So it's in my experience, it's a lot of modeling. A lot of you're working with a BA as well, functional testers, and low test model or models, okay, and then understanding what are those key metrics like HTTP response time, latency, CPU memory disk, all those things, okay, error rates, right? What's an allowable number of errors, right? And to factor that into your models or your load tests. Hopefully that answers your question. Okay, from Jason, are there any K8 specific things that need to be considered when designing load tests, or are load tests essentially platform agnostic? Yeah, I think this is getting to Max's first couple questions. In my opinion, there is really nothing. It's very much platform agnostic, because these load tests, they are designed for the web application and also what it's hosting for. Okay, I would say that number one. But your hosting platform has some auto scale design to it, then you want to use your test tool to test those boundaries and the auto scale functionality such that it works. And I think that was a point made or question made from Anthony, right? So you want to actually test the platform itself. Not that it's Kubernetes, right? But it can be a bunch of VMs in a scale set. It can be, any provider, but that has the auto scale functionality. Also, you want to test its monitoring capabilities too, right? Logging, application log, are those working appropriately? So you need to consider those kind of in your load tests as well. And you want to load test that it scales back down, appropriately. Okay. And yeah, actually another one that can come to mind is also you want to test how responsive the auto scale functionality works, because you can make the wrong assumption that, what, auto scale should auto scale quickly. That's the whole. But no, like as I mentioned before, in AAS, when it spins up a new node, that does take time. Like it's just inherent to VM startup, right? When you're loading up a VM, it goes to the Windows operating system or Linux operating, like just to load up. Provision the resources, allocate that, put it into the, software-defined networking from that cloud provider. So that takes time, right? So you want to test your load test, to test your platform for how long it does take to auto scale. So I think that's a very important consideration. So any other questions? You can even go off mute. Anything in particular that I can show in my demos, or I know I quickly went through the monitoring tools, but yeah. All right, so hopefully I've kind of showed you kind of real world, like a good robust demo that's, a bit sophisticated, showing many apps and kind of load patterns and memory usage on all those applications. So
Thank you very much, Roy.
yeah.
It was great. Thank you again. Anybody has any questions before we call it a day? All right. Thank you all. Thank you very much. The next session is on November 11th, I believe. And it's going to be on the Octopus, and it's going to be by the Octopus, by the architects from the Octopus people. It's going to be a very technical talk. So again, if you're interested in the Octopus, you should join us. And if you're not, it's still a good session to listen to. Great. Again, have a good night. Thank you all. Thank you, Roy.
Thanks, Roy.
Thanks, everyone.
Thank you. Bye, all.
Okay, bye.